Hello friends, welcome back to the bench. Today we have a SSD, yes, SSD NVMe. And so this came from the Surface Pro we worked on before. You remember I was resetting the Surface Pro for George, and after the reset, the computer would just keep spinning. I wouldn't get to the Windows. So I replaced the unit for George, but that unit is actually coming back. So the screen, it looks like those screens from Texas I was getting, they're no good. So out of two that I bought, one I broke with you guys watching me. The other one that I sent to George, when I took it out of the box, I immediately placed it, so I didn't play with it. I didn't toss it around or anything. I treated it like an egg. And well, according to my tests, it did work. It seemed fine. But as soon as it got to George, it started doing weird stuff like minimizing windows and stuff. So probably, yeah, the digitizer is crap. So I have another source. They come like this, so different packaging, and they come in a huge box, so also really nicely packaged. And I have quite a few units behind me that the screen can go on. So I want to see if I can get a refund or some good deal from those guys that sold me those screens, because so far on this repair I'm like $150 down, and plus this screen, so like $200. So that was the most unsuccessful repair I have done in a long time. But unsuccessful. Well, right now it's unsuccessful because George still doesn't have his Surface. I'm still waiting on that unit to be returned, and I will probably today or tomorrow I'll have the unit replacement unit for him on the way. He's in Florida, I'm in Georgia, so the shipping doesn't take too long. But as soon as George receives his computer, I call it a successful repair. Because what makes your shop successful? Making a lot of money? See, it kind of depends on what you're after. I opened the shop to satisfy my clients, right? You have something broken, perhaps I can fix it. I fix it, and you're a happy customer. That's why you would recommend me. You're not gonna recommend me saying that, hey, Raf made $200 off of me. So definitely go to Raf and allow him to make $150 out of you too. Well, that's not exactly how you advertise. That's not how you recommend stuff, right? So a successful repair is the one that actually makes the customer happy. So even though I'll lose money on this one, first, I'll have a satisfied customer. Second, I've learned a lot, and knowledge is expensive. No way around it. And it's not like the $200 is gonna make or break me, right? But that is my approach, and I know some other repair shops that measure their success based on how much money they make. Nothing wrong with that, but as long as you're transparent about that. Alright, and today, let's see. So this is the SSD, right? I already took the sticker off. Let's take the whole sticker. So this is 128, right? Let's take the whole sticker off. Not that it matters, but we are taking the whole sticker off because we're gonna do a little experiment on it. So this is working SSD, and for the life of me I cannot find the pinout of this connector. So, but I do know that this is ground. Now these two have 4.45 voltage drop, right, roughly, and the rest, some of these test open line, some like this one, some with voltage drop, so about 400, call it between 4 and 500. Now if we do the same thing on this one, we see that our voltage drop is 30, and on this one 31, right? So if we go to resistance, our resistance shows up as 50 ohms. So it's not a dead short, but it also is not good. How does it manifest when you connect it through the adapter to the computer? It will show up, but the computer will say immediately that that the device is there's something wrong with the device, and then my entire strip, what do you call it, the USB concentrator or splitter, whatever, stops working, and then I have to disconnect it from the computer, connect it again, and then it starts working again. So that's why I started looking into it, because it sounds like short. Now 50 ohms is not good, because what we could fix on it is one of these caps, right? But that would not show up as a 50 ohm short, that would be dead short, and finding one of these would be relatively easy, injecting voltage. But 50 ohms means that one of these chips is having issue. Probably not memory, but could be. Probably something here, here, or here, right? What happens when I inject 1 volt over here? I can't see anything heating up on the camera, which is not surprising. The only thing that's heating up is the the connector itself, so the point of contact is where it heats up. So this is not surprising, because if one of those chips is experiencing this short, it's going to dissipate the heat relatively quickly, and then spread it across the larger area, because these are big chips, and that's why we can't see which one is heating up. When the cap is shorted, it's small surface, so it'll just light up on the thermal camera like a light bulb. The chip, on the other hand, no. So what I'm gonna do is inject a little higher voltage, even above the safety level, and safety level is around 1.8. I usually stay around 1 volt. So in the effort of finding which chip is shorted, we will likely fry it. We will break this device even more. But since it's none of the caps are shorted, there's nothing I can do with it anyways. Maybe once we find which chip is shorted, maybe I'll keep it, just mark the chip as broken, and keep the rest of it for replacement parts. Or perhaps if I find more of these that are broken, perhaps I can just replace that chip and get this SSD working again. This is not data recovery. The customer doesn't care about this one. I was just curious. So let's solder in the wire and inject some high voltage. I'll start maybe with 2 volts and I'll go up from there. I won't stop until I know which chip is faulty. So I will be injecting as much as I need. Probably the limit would be around 5 volts, but at 50 ohms we don't need full 5 volts. This thermal camera should catch it very quickly. Okay, let's get some flux. And let's do an unsuccessful repair. Actually, this is just a satisfying curiosity. I just want to know which chip is faulty here. Okay, we are connected and we are drawing 50 milliamps at 1 volt. So now let's start increasing the voltage and inspect with the camera. Okay, I'll be able to see something. Yeah, it's all cold now. It's got some reflections, but okay. Now, let's turn it on. Yeah, nothing's heating up. Oh, there you go. Oh, no, that was just a reflection. Yeah. Okay, so actually there's a little heat spot. Is that a heat spot? No. Okay, now let's start increasing the voltage. 1.1. Yep. Okay, we have a very nice heat spot over here. So it's right here in the middle of this chip. So as expected, yeah, I don't feel it heating up with my hand, so that would be almost impossible. And this is only 1.2 volt, 123, and we're grabbing 146 milliamps. So that's 0.1 watt. And we have a very nice heat signature over here. So that answers our question. This is the chip. We didn't even have to break it actually to find it. But we did have to kinda break it to solder on the wire. So either way it is broken. Actually, you guys wanna just fry it up? Let's fry it up. Let's see what happens. One 3, 1 4, 236 milliamps. Now it's getting pretty nice and hot. We got 34 degrees. Yeah, so that would... I still don't feel it with my finger. That's not enough temperature. 0.6 watts, 0.7, 0.8, 1 watt. 2 volts, almost 500 milliamps. And we are up to 47 degrees. 49. Okay, let's keep going. Why not? 2.2. We're at 570. Let's go up to 2 watts. We're drawing 730 milliamps, 1.9 watt. The voltage is 2.7. We are at 70 degrees, 72. So we are approaching the maximum operational temperature. Semiconductors shouldn't work above 70, 72 degrees, something like that. 3 volts. So now we are approaching maximum voltage that this device should receive. It probably works on 3.3, but it could be 1.8. Who knows? Again, I couldn't find any pinout for this port for some reason. I was expecting to find it easily. 90 degrees, so we are above safe temperature. This is not breakdown temperature yet, but let's get there. 3 watts. Oh, and we went down. Yeah, so now, oh, see that? So some at 3.6 volts, something gave in. The chip is warm enough to detect it with my finger, but looks like that one little thingy, and this is probably what protects from over voltage. Let's see, which one is it? It is this one. Yeah. So over here, yeah, that's what's heating up. This guy over here. Get some pointing device here. That area is heating up. So this reacted. So that tells us that 3.3 volts is the maximum that this device can operate on, and as soon as we cross that threshold, this element reacted appropriately and started, well, it didn't start shorting, it went open because our power consumption went down. So it didn't protect it by shorting, it protected it by opening. And now our power consumption is 0.2 watts, 61 milliamps at 3.6 volts. Alright, we fried it, and our gentleman responsible is this one, and the heat spot is roughly here. So something in there, something in that chip. Now let's just take off that chip and see what's underneath. There shouldn't be anything interesting in there, but who knows? Since we already broke it, let's just, and actually let me do it this way, like this. And this is too high of a zoom. Let's move away a bit. There. So now let's go to maximum temperature, maximum airflow, no nozzle. And let's see if I can find the tweezers that can grab this chip. Because I don't think I have anything that would, yeah. This one definitely won't grab it. Let's see the big one. Barely. Barely. Well, it's like it was measured for this chip. Okay. So we could put some flux on it to speed up the process, but since I'm going to be operating with highest temperature, highest airflow, this shouldn't take too long. It's flowing. Almost. It's just not the proper tweezers for this job. Did I knock off anything? Yeah, probably this. Yeah, because it's complete. As soon as I lifted it, it skipped my tweezers. So this is not the best tweezers for this job because they're straight, like this. Right? They should be pointing at the angle. That's why I have these for QFN chips. These are bent, right? But it works like a kind of a claw, right? So it grabs the chip much easier and it holds it firmly. This is not exactly great, but the chip came off. What's underneath? Do we have stuff underneath? No. Okay. So now it would... So this is likely what is responsible for interfacing, right? These are definitely memory chips. 64 gigabytes each, I would say, because this is 128. This looks like something that has something to do with power, the presence of coils and caps around it. This is, who knows? And this must be responsible for interfacing with the M.2 and interface, right? So technically, if we found this chip somewhere on some other SSD, and if I didn't mess up taking off the chip, let's see if I ripped any parts, but I don't think I did. Oh, look at that. What? Oh, okay. That's the part of the sticker. I thought the chip broke. It's just the sticker. It looked like, yeah, like the chip was open. Weird. So, do we have any ripped parts? Possibly. Possibly. So let's see closer. I made sure it was floating before I pulled it, so I didn't expect any parts to be missing, but... Oh, no. Let's see. No ripped parts. Okay, so this came off pretty cleanly. So theoretically, if we had this chip, we could replace it. And that would be a data recovery, I imagine. Unless this chip is somehow paired with the memory. This could be a safety feature. Just like when you take out the SSD from the computer and put it in the other one with different TPM, it's not gonna be readable because it's BitLocker locked, right? But that is not exactly pairing. That's just a security feature, and you are free to disable BitLocker when you receive your machine. I personally don't put BitLocker on my devices, and if you do put BitLocker on your devices, just make sure that you put a decryption key on your USB stick, or or just store the password, the decryption key. You can create a USB key that will talk to the TPM and read read the code, read the decryption key. That would be my expectation, but I don't know. In either case, be aware that sometimes your computer will break, and you will pay a hefty price for data recovery if you have something like this. All right. So this seems like, suppose I had this and I didn't mess it up, because I would have to use different tweezers. But suppose I didn't mess it up. Well, actually, I could just clean it up and probably, I could probably fix this mess, no problem. But we have some solder on the cap over here, and I don't see any caps missing, but there might be like here. Maybe I messed up. Yeah, looks like something's missing there. Oh no, those are resistors here. Okay, yeah, so nothing's missing here. Let's see, solder over here. So this would be pain to get some solder over here. This would be a pain to get it working again. So definitely when taking off chips like this, instead of using tweezers, let's use a what is it called? Like a suction cup, for the high temperature suction cup, and that would allow me to pull the chip nicely. So this would be a nightmare. But since this would be considered data recovery, even though it's just replacement of one chip. Well, replacement of one chip, but this is BGA. Look how many balls we have to resolder here. And if I had this chip, I don't know, I can look for it, but if I got it from the legitimate source. Oh, this is ARM? Oh, so that's a CPU. Oh. You think that's what it is? The ARM. That seems like it should be a CPU, right? Maybe it is. It does heat up. Normally when these work, they do heat up. Let's see on this one. What do these one have? Yeah, so this is kind of an equivalent, but you see how way differently this one's made. And this one has 3 memory chips. Is this also 128? It should be 128. Oh no, because this is 256, that's why. So it's slightly different. I probably shouldn't be using this one for my reference. I should use something a lot more like this. But as far as the interface goes, it must be the same. I mean, the power consumption could be slightly different, but not, 0.031 versus 0.4, right? So there's no way this smaller memory takes 10 times more energy, right? And we still don't know what these 2 pins actually are responsible for. They could be powering up this device, but I would expect that it's the other side. These 3 are V+, and these 3 are ground. And that's how I would expect it to work, but we don't know. Anyways, this would be considered a data recovery. So, in my shop you'll probably pay maybe $200-300 for this, because it's a pain to rebuild this chip, and I likely don't have a stencil for it. I would have to dig through my stencils, but probably, I don't know. I always, whenever I have chips like that, I always find that I always have a stencil that is very close, but not quite there. I never have the right stencil. However, even with the not right stencil, not the stencil made for this chip, you can still rebuild it. It can still be done. And at the end of the day, you can just take the balls and just, place them one by one on this chip. I've done that before. It's a pain. It's a huge pain, as long as because if one of the balls just escapes, that's fine, because you can replace the ball. But if two balls touch and form a big ball, there's pretty much nothing you can do with that whole side. Let's say it especially if it happens somewhere in the center, like if it happens here, then you likely need to take off this entire area over here, still not messing up with other balls that did solder on correctly, that did melt correctly. So it's a pain. I have balls here somewhere. Yeah. So each one of these you just have to place one by one. That's why stencil is so much quicker, because you use solder paste, but it's not easier. Either way, this is pain in the butt. But that would be in my shop. I expect I wouldn't blame the other shop charging maybe $1,000 for data recovery this way. I would not be surprised, because data recovery is expensive, and it must be, because that means you messed up. You didn't take care of your data. And now someone needs to spend a lot of time and effort to get that data back. And now imagine what would have happened if after replacement of this chip, you find out that NVMe is bit locked and the client doesn't have a password. So technically, you can't charge for data recovery because you didn't recover the data, right? Yet you did crap load of work to attempt to recover that data. And that's the question, like, should you know, I know there's what's his name? I actually don't know his name, but he's a funny guy, the Northwest Repair, right? He recently makes a lot of funny videos mocking Alex from Northridge Fix. And he does do, because imagine turning your repair business into multi-million-dollar business. That is first time I've heard a story like that. There's not enough hours in the day to make that much money, so the majority of your money must be coming from bench fees. Which means, as a customer, I'm paying, say, $150 for basically for nothing. For repair attempt, fine, but I don't know. I mean, it is successful as far as the making money, but again, that's not what I would recommend. I wouldn't recommend Alex because he makes a lot of money, because he has a successful business. If I wanted to recommend someone, I recommend them based on their skills and their knowledge and stuff. Like Northwest Repair, I would not even attempt doing GPUs, because he's awesome at it. There's just I don't have the tools, first of all, to get it done, and I lack expertise. So why would I even attempt it? He's available, so I would just send it to him. But to Alex, I don't think I would offload anything to Alex, because his repairs are usually pretty basic, meaning like short finding, like in this case, perhaps identifying a cup, identifying a shorted MOSFET, obviously the HDMI port replacements and USB-C port replacements, because a lot of faults are like that. And these are easy, but these are like very generic. It's not like you have a deep knowledge, like you specialize in certain device, or types of devices. And Northwest Repair specializes in GPUs. That's all I've seen the guy doing, and he always gets to the bottom of it. And he's got all the tools necessary for that, for diagnostic and for actually working on GPUs. And these are fake boards. You do need preheater. You do need a lot of room to place that, to have all that. And plus all those power, what do you call it? The devices generating power to power up the card. If you want to stress test it, you need something that will deliver a lot of power. I mean, you can just use the regular ATX power supply, but you would like to know how much power is it drawing. So it's better to have something dedicated to working on GPUs, not just regular ATX power supply, although that you can do it. I attempted few repairs of GPUs. So far I have not been successful. I had one that was shorted. I couldn't find a short, or at least none of the caps were shorted. I didn't have a thermal camera then, so I was just using alcohol evaporation method. But when you inject the voltage, enough voltage to evaporate alcohol, I likely fried that GPU anyways. So, but I'm pretty sure the core was shorted. But it could have been one of the memory chips, and I just injected too high voltage because I couldn't get enough heat. So I injected way too high voltage. You shouldn't really go above 1.8. There's no reason, especially if it's dead short. Like here we went all the way to 3 volts, and on 50 ohms that already went up to like 100 degrees almost. It was in higher 90s. So you don't need a lot. You don't need a lot of voltage, not a lot of current to see it on the thermal camera. If you use the freeze spray or finger method that requires a lot more temperature, and it's very unreliable. Short finding without the thermal camera is difficult, and that requires skill and experience to actually identify the shorts without tools. And that has always been true. When I was about 2 decades ago, I was in my 20s. I was doing repairs, but not micro soldering. This wasn't exactly a thing back then. Plus, there was very little equipment being repaired that was microelectronics. And back then, I, like pretty much every repair technician, my only method and my only recommendation for microelectronics being broken is the replacement. No, you don't fix those. Those cannot be fixed. It's too small. That's how it was back then. And actually, I think it all started with Louis Rossmann. Like personally, first time I came across the Louis Rossmann channel, and I was like in awe. Like, you can actually work on these tiny components. It actually can be done. So anyways, I had this friend, the technician, and he was amazing. A lot of a huge amount of knowledge and skill in those hands and in that head. And so I always relied on plenty of equipment to find faults, and I would be semi-successful as long as I had a lot of equipment, meaning at least oscilloscope, about 2 multimeters, the frequency meter, capacitance meter, ESR meter, like all of that stuff, just to get some work done. And he could do the same thing just using multimeter. Instinct and experience, especially the power supplies and monitors, like high voltage circuits on the CRT monitors. Oh, he was a wizard. Few minutes and he knows exactly what's wrong with the monitor. But my point was that if you don't have enough skill and enough knowledge, you need to make up with having a lot of equipment, like a thermal camera. If you're like really good, you can find shorts without using thermal camera. And actually you can make your own what is it called, the micro ohm meter. It's basically the resistance meter, but on much lower scale. And if you can differentiate between micro ohms, milliohms, well, probably more than milliohms, so micro ohms probably. If you can differentiate with between those, you can find shorted components just by detecting that the resistance is slightly lower on that particular component. I personally haven't had a success with that, because again, I don't have enough skill to, not enough experience using this method. It's unreliable to me because you know, I put the probes differently in this place and that place, and slightly closer here, slightly farther apart there, and that all affects the measurements. So my measurements were always inconclusive, even if I had a pretty good equipment for measuring micro ohms. So you can there's two ways to be successful. You either come up with, you're either really good, really talented, or you make up with professional equipment. And I don't know, experimenting. I think experimenting is the best way to learn and to kind of gain experience. So you know, if you're thinking of starting a repair shop, just get some broken stuff from eBay, start repairing it. Unless you're in a situation where you just can't afford that, and that is too bad. There's not much I can recommend for that. This business is not exactly an easy business, and it's not exactly, typically, it's not something you will get rich doing. I mean, Alex kind of proves that you can, but I kind of question where that money, or what that money is going to him for. Because if, you know, I would be surprised if his repair ratio is above 50% or even 50%. Because making that much money, that means how many repairs can you do a day? Plus run your YouTube channel. So you have to record everything, then you have to you know, edit it and get it ready for the video, to the description, caption, you know, thumbnail. That's a lot of work. So to even do $1 million in a year, that means at least like $100,000 a month, right? Or well, a little less. In 10 months, if you can make $1 million, then that would be 100 grand a month, and that's gotta be just income, the clean net profit. So to make, oh my god, $100,000 a month, let's call it even 80. Let's do some math just for fun. You guys ever do math for fun? I do. $80,000 divided by roughly 30 days. That's $2,600 a day. So to make $2,600 a day, you have to go through, well, 10 devices, which you will charge $260 per each. 10 devices. Can you fix 10 devices in 8 hours? Well, if it's, primarily what I do is resoldering QFN chips on the car computers, right? On ECMs. That's like my money maker. I can do maybe 3 a day, maybe 4. Because doing more than 4, that would be unreliable. I would just be too tired. Plus, I don't have time to work, all day on the bench. And I also have to do the work that actually brings me money. I charge $100 for each, so I could do maybe $400 or $500 a day, if I had enough, business. Obviously, I don't have that, so I don't have that problem. It's a good problem to have, but I luckily don't have it. So maybe I could do $500 a day, having the repairs. On the other hand, if I had like big stacks of devices, and for each I charge $150 bench fee, then I can just go through them like fire, especially when I have someone else doing the disassembly and reassembly for me. I could burn through a lot of them, but then again, what's your business? Your business is just charging bench fees, or your business is in the repair? I know Lewis doesn't. He does a no repair, no fee kind of business. So that is, I respect that. I respect that a lot, because he stands behind his product, right? Like money back guarantee kind of thing. Alex, on the other hand, no, it's like you send me anything, you need to pay the bench fee, which is fair. Don't get me wrong. I'm not saying he's doing anything wrong or illegal or despicable. No, it's just not something I would want to do. Like it's not like I don't want to be rich, but I don't want to get rich on bench fees. Sometimes you win, sometimes you lose. Like with last repair, this SSD. Well, it came from that computer, but I lost money on this one, but I'm happy with it because the customer is happy, and I'll make it up on other repairs. Don't cry for me just yet. I'll survive. But I have a happy customer, and that's how I make connections with other repair shops, with my clients, and that's why they recommend me, and that's why they send more stuff to me. All right. So I like that. Maybe it's not a big money maker, but I don't know. Right now I do about $1.50 on average, maybe $1.20 on average a day on YouTube. That's pre-tax. So maybe $40 a month that I get from YouTube. So that's like a bench fee a month. I was also thinking, of subscription models. By thinking, I mean just thought experiments. I'm not planning on doing anything like that, but I was thinking, my bench fee is $35. So if you want to send me more stuff, then you can pay $35 a month, and you can send up to, say, 5 devices a month, and that monthly subscription covers that, right? Or maybe 3 devices or whatever. But some just set amount of devices. And you don't have bench fee, and that model is really good, and everybody loves subscription models, because that only works when you actually do have stuff for repair, and you're gonna be sending a lot of stuff to be repaired. But if you're an typical individual, and you'll quickly forget that $35 a month is leaving your account and joining my account, times 100 people, that's free money. So that's why subscription models are so successful. but it's kind of a predatory. It's kind of a predatory model, because the same idea is with the credit cards. You know how credit card companies will tell you that, you know, get a credit card if you pay it off every month on time. You get some bonus, you know, some extra gift cards, something, you know, equivalent of money or money equivalent. And there's very few. The reason they do it, because if you think about it, that's not great for them, right? It's not that hard to pay off the credit card every month, right? But the reason it works is because people are, as a group, are not great about paying off their credit cards, and stuff happens. If you have an emergency, you don't have cash. Well, you're gonna put it on your credit card, and that's what the credit card company counts on. Then perhaps you'll miss one payment. If you miss one payment, then the entirety of those benefits that you were getting from that card are nullified, and you're probably behind already, just with one late payment. Not to mention your credit suffers, and they know that. That's why they're gonna lure you in with the best deals that sound awesome, because they know at the end of the day you will slip up and you will eventually need to charge that credit card and keep the balance on it, because you just don't have money. So eventually they will get their money worth. So if you're thinking of getting a credit card just for that reason, just ask yourself, are you smarter than the credit card company? Are you gonna cheat the credit card company? You're gonna make money off of credit card company? That's very unlikely. Very unlikely. Just imagine the power they have, the resources they have. You know, lawyers on retainer, like armies of lawyers and accountants and analysts, and yeah, they know what they're doing. You're not gonna outsmart the credit card company. You're not gonna outsmart the bank. No, they are in the business of taking your money. It's like going to the casino and hoping that you're gonna get all the money from the casino, playing blackjack or poker or something, and yeah, maybe you'll get a lucky day, but at the end of the day, the casino will take your money, because that's how casino works. If you think you can outsmart casino, again, think of what resources they have to take your money. They're in that business for a reason. So yeah, definitely weigh your strengths before the battle. That doesn't really translate well, but but you know what I mean, right? Well, anyways, this video is all over the place. But I just wanted some consideration on and some reality. I just wanted to show you guys some reality of repair business. It's not always, because usually I like to post the videos in which I actually repair something and all those successful repairs, but I also have some unsuccessful repairs, and I don't post them for one reason or another. Sometimes I don't record them, sometimes I do record them, but then I figured, it's not gonna be a great video, or maybe it's too long, or maybe my sound went off midway through the video, or some other, couldn't catch the focus, or just deem the video not interesting, not worth my time to publish. Very little value in it, right? So I try my best to deliver as much value in each video as I can. So that's kind of my category, my criteria when it comes to whether I want to publish that video or not. So in this one, I just wanted to take you on a less successful repair, but that's another thing. You always need to have a plan B. I started working on Surface Pros, and I'm waiting for another one. So the first one was unsuccessful, but even no matter what happens, I have a huge pile of these, like literally piles of these. How many? Maybe around 30 right now that I have in stock. So no matter what happens to your Surface Pro, I will be able to repair it. And if not, I can just replace it with one of my from the pile. So that's my kind of guarantee. So if you send me your Surface Pro 4, you will have it fixed in either way. And that's kind of my guarantee. Because once, you can't be learning on customers' devices or getting the, let me rephrase that, because in my last video I was talking about that, it kind of came a little scrambled, and there was some backlash on that statement. Don't learn on customer devices. Well, be transparent about it. Meaning, don't advertise yourself as a specialist in Surface Pro 4 repair before you even repaired the first one. Or maybe you just repaired one and you advertise yourself as an expert in Surface Pro 4 repair, and you just learn on customer devices. So that is not good, because you're kind of cheating, right? So if someone sends you the Surface Pro 4 to be repaired, well, you need to at least, you need to be skillful in it. So yeah, I bought like tons of these before I received my first one. That's why I'm not worried about whatever is wrong with your device, right? So this one from George had a faulty SSD, but it worked before, so George suspected that perhaps it got damaged in the shipping. Possible. I would say unlikely, but it is possible. It will be kind of weird fault because it's kind of an electrical fault, right? You would expect physical damage, not a fault like this. But who knows? Maybe. As far as I didn't test the rest of it, but which one was that? Oh, this one's kind of interesting. This one. Let's grab a multimeter and put it here. And actually, let's do the resistance. So you see this, we have 5 ohms on this MOSFET here, right? So this between ground, that would be 5 ohms, right? So that's not a dead short, but that's way too low. This is VCore for this supplies the CPU. And this is one of the first voltages that will appear on the board. And the standby is generated here on this one, and this one was low, right? Because this is the first area you're gonna check. Actually, the first area you're gonna check is gonna be here, right? You wanna have 15 volts over here, and when this is controlled by EC chip, when you have 5 volts over here, then you're gonna have 15 volts over here, and then that goes to this resistor over here, which is always has 12 to 15 volts on it, be it from the battery or from the charger, and this goes to the battery, and this is our charging I described all that in one of the videos, how the charging circuit works on these. But since we have low resistance over here, that means the CPU is fried. No, 5 ohms. This should be closer to 20. So still pretty low. The meter will still beep on it. But how do you know it's not the MOSFET shorted? Well, again, if you have devices like thermal camera, you just inject 1 volt over here. Actually, at 5 ohms you can inject like 0.8, and that is roughly, because the voltage over here, the core should be 850, I think, 850 millivolts. So yeah, like inject 0.8, 0.9, and what is heating up? And in this case, what is heating up is the CPU. So that's how I know the CPU is busted on this one. That's why I couldn't get it to work. That is one fault that I cannot fix on these. So that would be the replacement of the entire motherboard. I will do the experiment and replace the entire motherboard, but I will resolder this. Underneath that shield is a TPM. TPM stands for Trusted Platform Module, and it's basically just a chip that holds your that is required to decrypt your SSD if it's encrypted with BitLocker. When you reset the computer, it clears the TPM, and yeah, so whatever was connected to it before can no longer be read. You don't have to reset the TPM, but I haven't tested that. I will test that though. But I'm very curious what's gonna happen if I just replace the TPM. Is it gonna... I replace the entire motherboard and the TPM, and perhaps even the BIOS. I don't think that would be required, because I do reflash the BIOS on these boards, and they read the encrypted SSD, no problem. The computer starts, everything's fine. So I don't think BIOS has much to do on these boards, as far as the security or pairing or anything like that. So maybe I'll just leave the BIOS as it is, but the TPM definitely needs to be transplanted for that to even have a chance of working, and I will test that, and that will be another service that I can offer. And I'm actually having a Surface Pro 7 coming, but it's only the display that is cracked. Nothing else should be wrong with it, and if that be the case, I should be able to just replace the display and sell that baby, because I kinda need money. It's been kind of a tough month so far. I'm also moving this week pretty much, so that's gonna be crazy. I need to move the entire bench, 150, 120 miles up north. So that's gonna be fun. However, I'll make a separate video on my move, because there's a lot of information I can give you guys regarding how to make your bench semi-portable and kind of a stress-free as far as the moving it. And I've moved it so far once. Well, actually twice. Well, once I didn't actually move it. I moved without my tools, and then I had to rebuild in Wyoming, and then from Wyoming I had to pack all my bench and bring it to Georgia. That was fun. 3 days driving 2,000 miles. And I'm the guy who hates driving. I hate driving, I hate traveling, and I drive a lot, I travel a lot. It's like kind of my life, what I do in life does not reflect my interests and my hobbies or anything. Well, other than the bench, and I do love software engineering. That's why I do it, and so I don't complain there. And I do love repairs and stuff. So yeah, these are my passions. But other than that, nothing I do is reflecting my interests. I hate travel. I hate driving. I don't know. I hate a lot of things that I do. Hmm. Such is life. Such is life, guys. No point in complaining. However, I am Polish, so complaining is what we do. So, there. That was my little bit of complaining. Okay, gentlemen and ladies, the 0.4% of my audience is female, and I expect the 100% of that is just my wife. So, but thank you very much, ladies and gentlemen, for watching, and I shall see you in the next one.